What if I told you the water you drink is older than Earth itself? The atoms in that glass, hydrogen and oxygen, began their journey long before our planet existed. These particles are cosmic relics, forged in the hearts of ancient stars and scattered across the universe. Every atom in you, me, and everything we see shares a common origin. This story doesn't begin on Earth, or even in our galaxy. It starts at the dawn of time and space. To understand our place in the universe, we must journey back to the very beginning. In a fraction of a second, every law of nature and every bit of matter was set in motion. This is the story of the Big Bang, the ultimate genesis. The atoms inside you are billions of years old, forged in cosmic explosions and stellar cores. You are, quite literally, made of stardust. We are all children of the cosmos, carrying the memory of the universe's first breath. Understanding this beginning is the key to understanding our place in the vast, mysterious universe. The Big Bang wasn't an explosion in space. It was the birth of space and time itself. Before it, there was no before, no space, no time, just a singularity, smaller than an atom, containing all the energy and potential for everything. In an instant, this singularity began to expand, space itself inflating at unimaginable speed. The universe started as a searing soup of fundamental particles, pure energy and chaos. As it expanded, it cooled, allowing the fundamental forces, gravity, electromagnetism, and the nuclear forces, to separate and shape reality. Quarks formed, then protons and neutrons, as the universe transitioned from energy to matter. It was like a cosmic steam cloud condensing into the first drops of water, the seeds of everything to come. The universe was still dark and foggy, but the ingredients for stars, galaxies, and life were now present. This was the moment the universe began to build its own rules. The stage was set for the cosmic story to unfold. From this chaos, order would slowly emerge. The universe's first moments shaped everything that followed, and it all began with a single extraordinary event. How do we know what happened at the dawn of time? Our time machines are telescopes. When we look at distant galaxies, we see them as they were millions or even billions of years ago. The farther we look, the further back in time we peer. Instruments like Hubble and James Webb let us witness galaxies in their infancy, revealing the universe's evolution. It's like flipping through a cosmic photo album, each snapshot a different era. By studying ancient light, we piece together the universe's history. But telescopes aren't our only tools. On Earth, particle accelerators like the Large Hadron Collider recreate the conditions of the early universe. By smashing particles together at near light speed, we glimpse the forces and particles that shape the cosmos. These experiments help us test our theories about the universe's birth. We are cosmic archaeologists, uncovering the past with light and energy. Every discovery brings us closer to understanding our origins. The universe leaves clues everywhere. We just have to know how to look. And with each clue, the story of the cosmos becomes clearer. In the 1920s, Edwin Hubble discovered that distant galaxies are moving away from us. The farther they are, the faster they recede. This meant the universe is expanding, not static. Imagine the universe as a rising loaf of raisin bread. As the dough expands, every raisin moves away from the others. It's not galaxies flying through space, but space itself stretching and carrying them apart. If we rewind time, all galaxies converge. Everything in the cosmos returns to a single, hot, dense point. This is the foundation of the Big Bang theory. The expanding universe points directly to a moment of origin. Hubble's discovery was the first hard evidence for the Big Bang. Since then, we found more. The faint afterglow of the Big Bang, the cosmic microwave background, fills all of space. This ancient light is the oldest in the universe, a baby picture of the cosmos. It confirms our cosmic rewind. The universe's expansion is a window into its past. Every galaxy, every star, Every atom traces back to that single moment. The evidence is written across the sky. The universe's story is one of constant change, from a single point to the vast cosmos we see today. How can something come from nothing? In quantum physics, nothing isn't empty. It's a bubbling foam of potential. Particles flicker in and out of existence in the quantum vacuum. Some physicists believe our universe began as a quantum fluctuation, a random blip that inflated into everything we know. The total energy of the universe might actually be zero. Matter and energy are positive, gravity is negative, and they balance out. In this scenario, creating a universe from nothing doesn't break any laws of physics. Did our universe spring from nothing? We don't have a definitive answer, but it's a real scientific possibility. The cosmos could be a natural, spontaneous event, a consequence of the laws of physics. Our existence might be the ultimate free lunch, a universe born from the potential of an empty void. The mystery of our origins is deeper than we ever imagined. The first 3 minutes after the Big Bang set the blueprint for everything. In the first second, the universe was a hot, dense soup of particles and energy. The four fundamental forces separated, and the universe cooled rapidly. Quarks formed protons and neutrons, the building blocks of atomic nuclei. A tiny imbalance left a small surplus of matter, which became everything we see today. As the universe cooled further, protons and neutrons fused to form hydrogen, helium, and a trace of lithium. This process, called Big Bang nucleosynthesis, set the chemical makeup of the cosmos. By the end of 3 minutes, the universe was about 75% hydrogen, 25% helium, and a hint of lithium. These abundances match what we see in the oldest stars and gas clouds. The universe was still a hot, opaque fog. Light couldn't travel freely yet. It would take hundreds of thousands of years before the first atoms formed and light could shine through. The universe had a beginning, and it will have an end. The most likely fate is the Big Freeze, a slow fading into darkness as expansion accelerates. Dark energy pushes galaxies apart faster and faster. Eventually, distant galaxies will disappear from view. Star formation will cease, and existing stars will die, leaving behind white dwarfs, black holes, and neutron stars. Over trillions of years, even these remnants will decay. Black holes will evaporate through Hawking radiation. In the far future, the universe will be cold, dark, and nearly empty. A quiet end of maximum entropy. All structure will dissolve, and time will lose meaning. The cosmic story will fade into an eternal, silent night. The vastness of the universe forces us to ask, are we alone? Our sun is one of hundreds of billions in the Milky Way, and our galaxy is just one of trillions. The ingredients for life are common, forged in stars and scattered across space. Some theories suggest our universe might be one of many, a multiverse, each with its own laws and history. Most universes would be sterile, but with infinite possibilities, some could harbor life. The multiverse remains speculative, beyond our current reach. For now, we focus on our own universe, where the search for life is just beginning. Thousands of exoplanets have been discovered, making the search for life a central goal of science. Finding even simple life elsewhere would be a profound discovery. It would mean we are not alone in the cosmos. Why do we care where the universe came from? Because we are part of its story. The Big Bang is our history, our ultimate origin. To ask about the universe's beginning is to ask about ourselves. For millennia, we've looked up and wondered. Now, science gives us real answers. The universe's story is more awe-inspiring than any myth. A cosmos born from a single point, evolving to create stars, planets, and conscious beings. This quest for knowledge drives us forward. Understanding the Big Bang has shaped our world and our perspective. It teaches us humility and highlights the preciousness of our existence. We are the universe's way of knowing itself. So we keep looking up, asking big questions. The search for answers gives our lives meaning and connects us to the cosmos. We are explorers on the greatest journey of all to understand everything. And that journey has only just begun.